So when completing synthetic division, there's a couple of things that we should remember. Starting off, synthetic division is dividing a polynomial with another polynomial equation of the degree 1. And synthetic division is generally used to find the zeros of polynomials. So first off here, we just have a simple example problem. We have 3x to the third minus 8x squared plus 11x minus 14. And then it's being divided by x minus k and x minus 2. So x has to be linear. This is going to be a rule throughout all of synthetic division. It just simply will not work if x is not linear. So we're going to break this down step by step. First off, we have x minus k, and we're going to equal that to 0. And then we have x minus 2, which is also equal to 0, which leaves us with x equals 2. So we're going to go over here, and I drew a sort of L-shaped line here that's going to help us complete this equation, and we're going to use it as a sort of table. So we're going to take the 2 from x equals 2, and we're going to place it on the outside. And then we're going to take all these numbers in the equation, 3, minus 8, 11, and 14, and line them up. Now, we take the number on the outside, and we multiply it by the other number. So for instance, here we have minus 8 plus 6, which is minus 2. And also in the beginning, you're supposed to bring the first number down. So we just do the same thing here. We line up the numbers, and we realize 11 plus minus 4 is 7, and 14 plus 1 is just going to stay the same. So we have our remainder as 0, our constant as 7, our linear variable as minus 2, and then the quadratic is 3. So then the answer would be 3x squared minus 2x plus 7. So here's a second example, but in this equation we're dividing two polynomials using synthetic division. Obviously the setup is a little bit different because we have two equations being divided. We're going to start off with 2x plus 3 equals 0. And then we're going to divide 2 on both sides. And so we're left with minus 3 over 2. So x equals minus 3 over 2. And we're going to draw the same sort of line structure and put minus 3 over 2 at the top of the line there. We're going to take the 3, bring it down, line up our numbers the same way we did in the last equation, and the math equals out to 3 minus 17, 51 over 4, and minus 113 over 8. Then we're going to have to write out the equation by taking each value that we have here and adding in the degree and adding in the x. So we have 3x squared minus 17 over 2x plus 51 over y plus 113 over 8 parentheses 2x plus 3. And that will be the answer. It was obviously a little bit more complicated than the first one, but the setup is still pretty similar. It's just the math is a little bit harder. So just some final takeaways is that x always has to be linear. The remainder theorem is crucial in solving synthetic division, and the degree has to always equal 1. These three things are incredibly important